Okay, so in this video, we're going to look at Exam 2 review problems. Please go to the lecture page and look at all the problems. But I will also write down all the problems in this video. Problem number 1, let's do that first. Problem number 1 comes from L15, practice 3. And let's write down that problem. This problem is solving this equation. Radical y plus 1 equals y. This one is a radical equation. To solve a radical equation, we need to isolate the radical part, which is this part right here. And the inverse operation, subtract 1 from both sides. And this will give us radical y plus 1 equals y minus 1. Next, we're going to square both sides. This is because the inverse operation of square root is square. So you square the left-hand side and the right-hand side. On the left-hand side, the square root and the square cancel out. We will have what's inside, which is y plus 1. On the right-hand side, it's y minus 1 squared. You could use formula or you could use the box to get what the answer is. So I'm going to use the box just to demonstrate how you could quickly get the result. We're squaring y minus 1, so it's y minus 1, y minus 1. And then you just calculate the area of each box that you see. The first box area is y squared, and then we have negative y, and the last one is negative 1 times negative 1, which is positive 1. And then you add them up. That's your right-hand side. And when you add them up, notice that these two are like terms. So you're able to combine them. If you add them, you're going to get y squared minus 2y plus 1. Let's put that on the right-hand side. Okay, so this is our equation so far. It's a quadratic equation, which means I'm going to move everything to one side, 0 on the other side. Notice that the y squared is positive on the right-hand side. That means I'm going to move everything to the right-hand side. So inverse operation, subtract y, subtract 1, and you do the same thing on the right-hand side. On the left-hand side, they all cancel out. It will be a 0. That's what we want. On the right-hand side, combine like terms. We have y squared, negative 3y. Positive 1 and negative 1, they cancel out. So it's just going to be y squared minus 3y. This is a quadratic equation that can be solved by factoring. So I'm going to take out the GCF on the right-hand side. They both have y. So you take out y, and then you divide the original y squared minus 3y by y. Y squared divided by y, that's y. Negative 3y divided by y, that's a negative 3. So the right-hand side is simply y times y minus 3. And because it's a product, which is 0 on the left-hand side, it's a 0 product. According to 0 product, each of the factor could be 0. So y could be 0, or y minus 3 could be 0. And the first one, y is already solved. Y is 0. The second one, we're going to plus 3 on both sides. And that will give us y is 3. For radical equation, you need to check if the solution is right. So let's check. This is very important. When we solve quadratic equation, we didn't need to check. It's because there are no restrictions in terms of the value of the variable. But for radical equations, we do have restrictions, which requires the radicand to be non-negative. So in this case, we are going to plug these back into the original equation and check. So let's check the first one, y equals 0. We put this back into the original equation, which means we have square root of 0 plus 1, question mark equal sign, and 0, right? So we replace the y with 0 in the original equation. This simplifies to square root of 1 plus 1, question mark equal sign 0. And that's 1 plus 1, question mark equal sign 0. Apparently, this is false because 1 plus 1 is not 0. So this is, the first solution is eliminated. Let's check the second one. Second one is y equals 3. We're going to replace y with 3. So that would be square root of 3 plus 1 plus 1. And then you have question mark equal sign on the right hand side is also 3. This is square root of 4 plus 1 question mark equal sign 3. And that's 2 plus 1 question mark equal sign 3. This one is true. So we can box the second solution. Y is 3. And that's problem number 1. Let's move on to problem number 2. Problem number 2 comes from L16. Example 5-3. Let's write down that problem. 2 plus 5i divided by 5 minus 2i. So our job is to simplify this, rationalize, so that we will get a result. If you remember, the way we did in this problem is we multiply both the top and the bottom by the conjugate of the denominator. The conjugate have the form of a plus b and a minus b. So right now we have 5 minus 2i in the denominator. We're going to multiply this by its conjugate, which is 5 plus 2i. So you're going to do the same thing on the top. Multiply the top by 5 plus 2i. And let's carry out the computation right here. For the bottom, I'm going to use a formula. The formula for, because this one right now, it's a minus b times a plus b, right? So the formula suggests that this is simply a squared minus b squared. So that means I'm going to have 5 squared minus 2i squared. That's for the bottom. And then for the top, I'm going to do a box to find out what it is. So let's do a box. And I'm going to divide the sides. So I have 2 positive 5i and then 5 positive 2i. And then we're going to multiply to find the area of each box. 2 times 5 is 10. 2 times 2i is 4i. 5i times 5, 25i. 5i times 2i, that's 10i squared. And notice that I squared is negative 1. Right, I squared is negative 1 by definition. So this is negative 10. And then if we add them, we will notice that these two will cancel out. And the other diagonal, 25i plus 4i, that's 29i. So 29i goes to the top. For the bottom, let's actually calculate what this is. So I'm going to move this somewhere else. Let's move it here. We got 5 squared minus 2i squared. That is 25 minus 4i squared. And notice that I squared is negative 1. So this is 25 minus 4 times negative 1. And that can be simplified to 25 plus 4. And that is 29. Let's put that on the bottom. So we have 29i divided by 29. 29 is a common factor, so you could cross it out. And the final answer is I. And that will be the final solution. Okay, moving on to, let's add a page. Moving on to problem number 3. Problem number 3 comes from L16, practice 4, which is about the cycle of raising the power of I. So if you raise the power of I, you are able to find a pattern. Let's do the pattern again. So I to the first power is just going to be I. And then I to the second power, it's going to be I times I, right? And by definition, that is -1. I to the third power is I squared times I. And we just noticed that I squared is -1. So it's -1 times I. That's -I. And then I to the fourth is I to the third times I. I to the third we computed just now, which is -I. And then we multiply by I. So this will give you -I squared. And remember, I squared is -1. So this is -1, which is +1. And then if you keep raising your power, I to the fifth, it will be I to the fourth times I. I to the fourth is 1, so it's 1 times I, which is I. So basically, this goes back to the original for the next cycle. So there is a cycle of 4 going on right here. It starts with I, right? And then it goes to -1, -I, and then 1. And then after that, it just goes back to the beginning. So how do you use this to compute powers of I? The question wants us to calculate I to the 92th power. So all you need to do is you're going to divide this exponent 92 by 4, because we have 4 different patterns for a cycle. So you're going to look at the remainder of this long division. The remainder will tell you which pattern you'll be looking at. So let's divide 92 by 4. This will be, first it will be 2. 2 times 4 is 8. So we have a remainder of 1. And then we drop 2. Now we're dividing 12 by 4. That's 3. And there is no remainder. No remainder means it's at the end of the cycle. So as you can see right here, no remainder, right? It's a 0. No remainder. And that means it's the end of cycle. Which pattern is at the end of the cycle? It's 1. So that means I to the 92th is 1. So here, let's do a little summary, right? So what happens if your remainder is not 0? If your remainder is, let's say, 1, then it will be the first pattern. What's the first pattern? I. If your remainder is 2, then it will be the second pattern. What is the second pattern? It's -1. If your remainder is 3, it will be the third pattern. Third pattern, -I. You will never get a remainder that's 4 because we're dividing by 4. The other one will be remainder is 0. So that will be the end, which is the fourth pattern. And that is 1. So this will be the summary of this problem using the pattern of I to find out a power of I. That's problem number 3. Okay, let's move on to problem number 4. Problem number 4 comes from L16 again. This time it's practice 3-2. 3-2. Let's write down this problem. This one is -2 plus square root of -a times 3 minus square root of -18. Okay, this is a FOIL problem. Before you do FOIL, you need to do some simplification. Specifically, you will be simplifying these two numbers right here. These are radical numbers where the radicand inside is negative. So how do you do this? You're going to use splitting, right? First one, -a. Square root of -a, you're going to split into square root of a and square root of -1. And then for square root of 8, we can split into 4 and 2. So that would be square root of 4, square root of 2. And for square root of -1, it becomes I. And then after that, you simplify square root of 4. So this becomes 2 radical 2I. Now let's do the same thing for square root of -18. You will split into square root of 18 and square root of -1 first. Next, splitting 18 to 9 and 2. And square root of -1 becomes I. Next, simplify square root of 9, which is 3. So it's 3 square root of 2I. Now let's put them back into the expression. So you have -2 plus 2 radical 2I. And then parentheses 3 subtract 3 radical 2I. Okay, so this is a FOIL problem. I'm going to use the box to calculate, just like before. Because in my opinion, I think the box is the best way to organize the products. So we have -2, positive 2 radical 2I, 3, -3 radical 2I. Let's multiply. -2 times 3, -6. -2 times -3 radical 2I, 6 radical 2I. Positive 2 radical 2I times 3, 6 radical 2I. Finally, 2 radical 2I times -3 radical 2I. You're going to multiply the corresponding numbers. So first, 2 times -3, -6. Radical 2 times radical 2, that will be positive 2, because it's radical 4, which is positive 2. And then I times I is I squared. So this will be the first product that we have. And then we're going to further simplify. It becomes -12 times I squared is -1. So that is positive 12. All right. And now we're going to add these 4 numbers. It's the diagonals, right? Diagonals will be the same type of number. So if you add those two, I will get positive 6. And then you add these two. These two will give you positive 12 square root of 2I. And that will be the final answer that we put right here. Okay, so that's problem number 4. Let's add a page. We're going to move on to problem number 5. Problem number 5 is prove the quadratic formula by solving ax squared plus bx plus c equals 0. So it's completing the square. This is L19, example 1. So I'm not going to demonstrate that again. I want you to go to the video lecture for this handout and watch the video. It's the first example that I did in the video, so it should be pretty easy to find. And then you can create a cheat sheet for this one. We're going to move on to problem number 6. Number 6 is L20, example 1. It's a problem that we did recently. It says find the base and height of a triangle whose base is 4 inches more than 6 times its height and has an area of 456 square inches. So for this one, if you remember, we started with graphing a triangle and then we labeled this triangle, right? So I'm going to first do a height. The base is B and the height is H. And we created 2 equations. The first equation comes from the translation for base is 4 inches more than 6 times its height. So it translates to B equals 4 plus 6H. That's the first translation. The second translation is an area of 456. The area for a triangle is B times H divided by 2. And this is 456. And that's what we did in class, the 2 equations. To solve these 2 equations, I'm going to first label my equation. Equation 1, equation 2. And the best way to solve is substitution. Substitute 1 into 2. This is because equation 1 b is already isolated. So you simply replace b in equation 2 with this part right here. Let's write that down. So you will get 4 plus 6h times h divided by 2 equals 456. And then we divided this part, right, by 2. This is because we have a product right here. So if I divide this product by 2, I can simplify by dividing the GCF of this part by 2. So dividing that by 2, I will get 2 plus 3h and multiply by h equals 456. And then we distribute this h. We obtain 2h plus 3h squared equals 456. And this is a quadratic equation. I'm going to move everything to the left-hand side because the h squared is positive on the left-hand side. So I subtract 456 on both sides. And I'm going to reorder my terms a little bit. Highest term, 3h squared plus 2h minus 456 equals 0. To solve this equation, you could solve it by factoring or by quadratic formula. I believe we factored in class. To factor this, you first do 3h and h. This is because 3h times h gives you 3h squared. And then for the other two numbers, it's going to be positive 38 and negative 12. So it might take some time for you to factor it completely, but this is basically how you factor it. And then by the zero product property, each factor could be 0. So 3h plus 38 could be 0. H minus 12 could be 0. The first equation, if you solve, you're going to get a negative solution, negative 38 minus 3 over 3. But because you know the height of a triangle cannot be negative, so this one will be eliminated. And the second one, you will get h is positive 12. This one is acceptable, right? And to find the base, we are going to use the first equation. First equation says that base is 4 plus 6h. So we're going to use that. 4 plus 6 times 12. And this will give you our base, which is 76. The units in this problem will be inches. So let's put that. And then for the final answer, you box these two. And that's problem number 6. Problem 7. That's the last problem on your second exam. This one uses the quadratic function. It says the quadratic function h equals negative 16t squared plus 128t plus 32 is used to find the height of a stone thrown upward from a height of 32 feet at a rate of 128 feet per second. How long would it take for the stone to reach its maximum height? What is its maximum height? For this one, you will use the formula of a parabola because the graph of a quadratic function is a parabola. And then because it's talking about the maximum height, you're looking at the vertex of the parabola. So let's do a visual of this first to help you visualize the parabola. It says that the stone is thrown upward from a height of 32 feet, right? So let's do that. And so this will be 32 feet. And the stone is like right here. Let's say this is the stone. And it's throwing upwards. And if you know gravity, you will know that eventually it's going to fall, right? If you fall, the curve will look like a parabola. So this is the parabola. And then at the maximum height, which is this point, this is the vertex. And we do know the equation of this parabola. The equation is h equals negative 16t squared plus 128t plus 32. So all you need to do is use the formula for the vertex. The vertex has a formula of x equals negative b over 2a. But in this case, our x is t. That's the variable that you see on the right-hand side. And the vertical axis is height, which is h. So we're looking at the vertex at t. You're going to use the formula. It's negative b over 2a. So let's plug it in. What is our ABC, right? Our A is negative 16. B is 128. We don't care about C because the formula doesn't have C. So it's just negative b over 2a. And that is negative 128 over negative 32. And then if you simplify this, you will get positive 4. And the unit is seconds because our t is time, it's in seconds. So this will be the first part of the question. At what time will the stone reach its maximum height? It's after 4 seconds. That will be the answer to the first part. The second part is asking you the maximum height, which is talking about this vertical distance, right? What is this vertical distance? So you're going to plug this t equals 4 into the original quadratic function. You're going to get the h maximum. So the h maximum will be equal to, you just plug in t equals 4 because that's the x coordinate of the vertex. In this case, it's the t coordinate. So let's plug it in. Negative 16 times 4 squared plus 128 times 4 plus 32. And for this one, I highly recommend you use your calculator. Just plug it in and calculate. You will get 288 feet. And that's the maximum height. And that concludes everything that will be on your exam 2. The problems will be very similar to these. So make sure that you review all of them. If you need to do more than one time, do that. And good luck on your second exam. Thanks for watching.